Here's sample test 2, problem number 6. A small 5-gram plastic ball suspended by a 15 centimeter long string in a uniform electric field of 1,000 newtons per coulomb as in the figure at the left. The ball has a charge Q. If the ball is in equilibrium when the string makes a 10-degree angle with the vertical, what is Q? Well, if you hear the word equilibrium, you're probably thinking net force is 0. And hence we want to make ourselves a free body diagram. So if we look at this, we are going to have a force in the x direction due to this electric field equal to QE, because this is a charge Q here. And we're going to have a force of gravity going straight down, if I can get this to go, equal to mg. And then there will be a tension force along this cord going like this. And because of these three forces, this mass and charge does not move. So it's in equilibrium. Well, if I were to extend the vertical down here, we would see that this angle right here is also theta, because two internal angles of two parallel lines separated by an intersecting line, the internal angles are equal. So that angle is theta right there. And so if I were to break up the tension T into its components, I would have a vertical component here. That would be equal to T cosine theta. And then I would have a horizontal component here. That would be equal to T sine theta, the opposite the angle theta. So in the x direction, we could basically see that T sine theta is equal to the electric force QE. And likewise in the vertical direction, we have that T cosine theta is equal to the weight force mg, because they're all canceling out in terms of components. Well, if I look at this, if I divide the left-hand side and divide that right-hand side of equal amounts, the t's will cancel out on the left-hand side, and I'll be left with sine over cosine, which will give me that the tangent of theta is equal to QE divided by mg. Let's solve this for Q, and we would have that Q is equal to mg tangent theta divided by E. Just solving that for our charge Q, and if we put in our values, we have 5 grams, which is 0.005 kilograms, times G, 9.8. Tangent, we were told it was 10 degrees from the vertical, tangent of 10 degrees, over our E field, which is 1,000. So evidently the length of the string is not going to matter here. And what is the value of that? 8.64 times 10 to the minus 6 coulombs, or 8.64 microcoulombs. So that is the charge on this charge, because in equilibrium all the forces must cancel out to add up to a net force of 0. So the charge is 8.64 times 10 to the minus 6 coulombs.